Good morning, this is Mr. Keaton. I'm here to talk to you about section 1.2, segments and congruence. Probably one of the most important postulates we'll have in this chapter. It gets used over and over and over. Anyways, we have some vocabulary here. First, postulates and axioms. Postulates and axioms are things that can be accepted as true without proof. The key here is without. And down here, yeah. So we'll have some examples of that in a second here. Theorems are true based on postulates and axioms. So we build theorems based on things that we accept as true without proof. We'll have a whole bunch of these coming down the road. Postulates and axioms, we have very few, but they build all our theorems. Some abbreviations over here on the left for theorems. Coordinate is the name of a point. Or distance is the length of something. Length is always positive. Between given 3 points, we can say one point is between the other 2 points as long as it is collinear. And we had that word collinear in our last video. Means it falls on the line. So all 3 points have to be on the line. So it's between if all 3 points fall on a line. Congruent segments. 2 or more segments are congruent if they have the same length. And we have a symbol for congruent. It looks like the equal sign, except it has a little squiggly line above. It just means they have the same length. Not the same line, but the same length. Going on to the next page, make sure you get that vocabulary in your notes. So here we go. Everything in geometry is proof, and we use postulates and axioms to prove things. But postulates and axioms are accepted without proof, and we'll use those to build other theorems. So we're going to use segments and congruence today. So here's your first postulate. Make sure you get this one down. The ruler postulate says that real numbers that correspond to a point is the coordinate of the point. So this is point A, and it has a point coordinate of x1. It might be, for example, 3. This is called point B. It has an x coordinate and it could be, for example, 5. So every point that has a name has a coordinate value also. It can be matched 1-to-1 with a real number. So, for example, 3, 5, or it could be 1.6 or 2/5. The distance between points A and B. Distance is written as AB. This does not mean line segment AB. It means distance. So the distance between points A and B is called AB, and it's equal to the absolute value of those coordinates. So the absolute value. That means we subtract them and make them positive. Now we have measure the lengths PQ to the nearest 1/10 of a centimeter. Everything in geometry is a diagram, so we can draw it. So for question number 1 in your video tonight, I'd like you to measure that on your screen to the nearest 1/10 of a centimeter and tell me the answer. Going on to adding segment lengths. Well, it seems fairly obvious that this plus this is going to equal that. So this would be 5 plus 2, which is 7. Over here, this point is not collinear. Not collinear. And thus is not between D and F. Not between D and F. So this brings up the segment addition postulate, and we'll look at that next here. Simply says that when you add 2 segments together, they're equal to the total segment. Segment addition postulate. That postulate gets used over and over. For example, in this problem, we could say, conditional statement right here. If B is between A and C, that means they're collinear, then AB plus BC, the length of AB and the length of BC will equal AC. That's the segment addition postulate. The converse also applies, which is simply the opposite. If AB, the length of AB and the length of BC equals AC, then B is between A and C. And we can go ahead and use that. Use the segment addition postulate here to find XZ. Well, that'll be XY plus YZ will equal XZ. Or simply 23 plus 50 is equal to 73. Hence XZ is 73.